When a Dutch company ships one of its most advanced machines to a customer, the shipment requires roughly 250 separate crates and multiple Boeing 747 cargo flights. Inside those crates, mirrors polished so precisely that if one were scaled up to the size of Germany, its largest surface imperfection would still be under a millimeter tall. That machine is an EUV lithography scanner, built by a single company, ASML, and every advanced computer chip on Earth, and every AI system, every smartphone, every precision-guided piece of technology pass through one of these machines before it exists. Chip making begins with lithography. Lithography printing, to be specific. Lithography printing microscopic circuit patterns onto silicon wafers using precisely controlled light for the most advanced chips, the kind of powering current AI systems. That light needs an extremely short wavelength in the extreme ultraviolet range to print circuit features small enough to matter, generating, focusing, and precisely directing light at that wavelength reliably at industrial volume. Turns out to be one of the hardest sustained engineering problems ever solved commercially. And exactly one company on the planet has solved it. ASML's EUV scanners work by firing molten thin droplets, 50,000 of them every second, with laser twice each, to create plasma at roughly 500,000 degrees Celsius, hot enough to emit extreme ultraviolet light. That light is then captured and directed using a series of ultra-precise mirrors built by the German optics company Zeiss, or to be specific, Zeiss, of Gut Deutsch, held in near-perfect vacuum alignment to tolerances measured in picometers. Picometers, fractions to be specific, fractions of the width of a single atom. The complete system contains roughly 457,000 individual components, sourced from more than 5,000 suppliers across 17 countries, assembled into a machine roughly the size of a double-decker bus. ASML holds 100% of the global EUV lithography market, not a dominant share, the entire market, along with roughly 94% of the broader lithography equipment market overall. The company has shipped roughly 314 EUV machines in the technology's entire history and produces only about 50 to 60 new units per year. The production rate is not a minor operational detail. It functions as a hard physical ceiling on how quickly the entire world's leading-edge chip manufacturing capacity can expand in any given year, regardless of how much capital any company or country is willing to spend. In June 2026, this checkpoint became the center of a live, unresolved diplomatic dispute. U.S. Commerce Secretary Howard Lutnick reportedly told ASML's senior leadership in private meeting first reported by Bloomberg that he believed an EUV machine or component specifically designed for one had reached China in violation of export controls in place since 2019. ASML has categorically denied this, stating it has never shipped an EUV system or purpose-built component to China, and that it can account for every one of its machines through continuous remote telemetry. As of this recording, no publicly accessible evidence supporting the allegation has been presented by the U.S. administration, and the matter remains unresolved. A genuine ongoing dispute rather than a settled fact in either direction. It is worth understanding why this monopoly has persisted for as long as it has, because it isn't simply a matter of guarded trade secrets. ASML invested more than 10 billion euros in cumulative research and development over roughly 2 decades to make EUV lithography commercially viable at all. An R&D commitment sustained over a time scale most companies and even most governments struggle to match without interruption. The barriers to replication aren't purely financial. Either they are deeply institutional and time-based, requiring the accumulated tacit engineering knowledge of thousands of specialists across dozens of suppliers, companies, refined through decades of iterative manufacturing experience that can simply be purchased or reverse engineered in a shorter time frame. Even ASML's own next generation high NA EUV systems, an incremental advance on the current technology, are constrained by how quickly its optics supplier size can manufacture optics to an even more demanding specification, meaning the pace of lithography advancement industry-wide is currently gated by a single optics company's production capacity. One further layer down the same concentrated supply chain. China has not stood still against this restriction. Reuters reported that China has built a prototype extreme ultraviolet lithography system of its own, a genuine technical milestone. So independent analysts caution that Peking has a documented track record of overstating semiconductor equipment breakthroughs, and that even taking the claim at face value, commercial viability likely remains years away. Plausibly, not before 2030. The more immediate and consequential workaround has been different. Chinese chip makers have become adept at enhancing older, non-restricted deep ultraviolet immersion lithography equipment tools not subject to the same export controls, using them through repeated multi-patterning techniques to produce chips that come uncomfortably close to what EUV would normally be required for. Chinese entities reportedly accounted for around 70% of ASML's deep ultraviolet immersion tools and tool sales in recent reporting, a volume that policy analysis and analysts increasingly describe as a meaningful loophole in the broader export control regime, even as the most cutting-edge EUV-dependent chips remain comparatively well protected. The strategic significance here extends far beyond any single company. Export control authority over ASML's technology is exercised jointly by the Netherlands, where ASML's is headquartered and where export licensing is a national government competence, and the United States, which hold real leverage because American companies supply critical subcomponents inside and around the EUV ecosystem. Cymer and ASML subsidiary based in the US builds the light source. American companies dominate key adjacent equipment categories like deposition and metrology, and American firms dominate the design software the entire chip industry depends on. That layered multinational dependency is precisely why a single Dutch company's shipping manifest can become a matter of serious diplomatic tension between two entirely different governments. The checkpoint is real, but no single country fully controls it alone. It is a genuinely strange feature of the modern global economy that the fate of the entire AI industry and a meaningful share of great power technological competition ultimately runs through a facility in Veldhoven, the Netherlands, building machines that only 50 or 60 times a year at a pace no amount of money can currently accelerate. Understanding where that kind of concentrated leverage actually sits, not where headlines suggest it sits, is exactly the discipline this kind of analysis is for. Thank you so much for your presence. Hope this has been very interesting to you as it has been to me, and I'm really looking forward a meaningful discussion. If you have any questions, reflections, feedback, Feel free to share them. Make sure I'll respond to them all as soon as I see them. And I'm really looking forward to see you and to join you in the next deep dive. Till then.